Welcome to qnawire.
The objective is to perform various calculations related to crystal structures, including determining APF, cell volume, and space volume. 1. The atomic packing factor APF for simple cubic SC is calculated as follows: APF equal to number of atoms per unit cell x volume of each atom / volume of unit cell in SC. There's only one atom per unit cell, and the volume of each atom is 4/3 pi r3, where r is the radius of the atom. The volume of the unit cell is a 3, where is the edge length of the cube. Therefore, the APF for SC is APF equal to 1x4/3 pi r3/3. 2. To calculate the APF for tungsten, nickel, and zinc, we need to know their crystal structures and the number of atoms per unit cell. Tungsten has a body minus centered cubic BCC structure with 2 atoms per unit cell. Nickel has a face minus centered cubic SCC structure with 4 atoms per unit cell, and zinc has a hexagonal close minus packed HCP structure with 2 atoms per unit cell. Using the same formula as above, we can calculate their APF values. 3. When titanium changes from HCP to BCC, its volume and APF will change. The change in volume can be calculated as follows: delta V/V equal to VBCC minus VHCP/VHCP, where VBCC and VHCP are the volumes of the BCC and HCP structures, respectively. The change in APF can be calculated using the same formula as above, but with the number of atoms per unit cell and the volume of each atom for each structure. The values of A and C given in the question can be used to calculate the volumes of the two structures. 4. To calculate the cell volume of zinc HCP type, we can use the formula V equal to 3/2 square root 302, where and C are the lattice parameters and square root 3 is a constant for HCP structures. The value of APF given in the question can be used to calculate the volume of each atom, which can then be used to calculate the number of atoms per unit cell. 5. To calculate the APF for titanium type HCP, we can use the same formula as in question 1, but with the number of atoms per unit cell and the volume of each atom for the HCP structure of titanium. The value of Cl given in the question can be used to calculate the lattice parameters. 6. To calculate the space volume in gold crystal, we need to know the crystal structure and the lattice parameter. Assuming gold has an FCC structure, the space volume can be calculated as follows: V space equal to V unit cell minus number of atoms per unit cell x volume of each atom, where V unit cell is the volume of the unit cell, which can be calculated as 4/3 for SCC structures, and the volume of each atom can be calculated using the atomic radius of gold. The value of a given in the question can be used to calculate the volume of the unit cell.